It's a pleasure to be here. Obviously, a lot of distinguished people talking so far. I'm very impressed with all the brain power in the room here. I come from the manufacturing sector, so I work for Schneider Electric, which you may have heard of. It's a large multinational company based primarily from a headquarters point of view in France. So we're the leaders in, we like to say, green energy and energy management, as well as in operations management, industrial automation, home and building automation, and different things like that. And I've worked personally in the automation industry for about 20 years now. I started off with Honeywell. I was there for about 10 years, and then from an acquisition that Schneider Electric had in Vensis, I've been working for about 10 or 11 years also in that area. And talking about the different things that have been talked about here, I think what I can bring is a little bit of an understanding of the industry from a manufacturing point of view, and also how technology applies to that. So what I'm going to do here is I'm going to kind of present a little bit to my presentation, but I'll just do it from a speaking point of view. So some of the things that are going on right now in manufacturing, there's definitely a lot of trends that are going on and technologies that are being used to address those trends. So when I started off working in manufacturing in Honeywell back in '91, I was the youngest person working in my team, and I'm still one of the youngest people working in my company. So there's a massive number of people that are reaching the retirement age now, and even beyond it now, from the manufacturing. These are working in the vendors that deal in the manufacturing sector, but also in the manufacturing companies themselves. So the aging workforce brings a lot of problems with it around how do I capture the knowledge. A lot of that's data-based, right? Data information I can pull together. And how can I also apply technology and meet the needs of the new emerging workforce, the young people out there? Because we were talking a little bit about lunch at these young people, the way they think, the way they operate, what they're used to working in is so much different from the older folks, right? At the same time, in manufacturing, a lot of the things they worry about is safety, for example, like a big oil refinery, for example. There's lots of things you're boiling at a high temperature that can explode. So a lot of things can go wrong. So how do you train people to do that more effectively for the new workforce coming in? Whether it's in the United States or it's overseas, where you have just these new big mega factories that are going up as part of that. So from a technology point of view, there's also a lot of things that are happening. There's mobile solutions that are coming in, and if you look at the way manufacturing works, it usually lags the IT industry by about 3 or 5 years. So when you start seeing a lot of mobile apps coming out and people are using things in Facebook, then you start seeing like mobile reporting and things like that coming out for handhelds for manufacturing companies and for oil and gas companies, for example. And there's also a lot of other technologies that are coming, for example, gaming technology. It's a really, really important thing. So you can basically develop today simulations that will work in a manufacturing plant, and you can train people on how to operate that plant. And from an oil refinery, for example, it's a continuous process. It's constantly taking oil in, and it's making gasoline and motor oil and tar and other things that are used in the market. In order to start up that plant, it takes about 3 days to actually get everything up and running and moving in the right direction, and it going continuously producing that material. At the same time, you got lots and lots of raw material coming in, oil and things coming out the other end. So all that needs to be coordinated as part of that. So allowing training systems that can be applied, and training systems that are built more like the computerized games you see today, like Halo and things like that, where you can actually simulate more expressively what they're seeing inside of the plant. They can walk around, they can open valves, they can start to do things inside of that environment that they're used to and they grew up in, right? So being able to apply those new technologies to the younger workforce is very important. And then from a manufacturing point of view, it also is very much about productivity. So being able to be productive, constantly tuning the process, and closing the loop as part of that too. So where you can, from an automation point of view, I think a lot of people know automation systems. You got this factory worker, he's sitting in front of a machine, or she is, and they're manipulating that machine, turning it on and off. and there's like a loop of control that's going on at that level. That loop is constantly being extended into other parts of the business, from the shop floor to the operations area to the enterprise, and even across the supply chain, and constantly tightening up that activity to make things more efficient. So a manufacturing company really can't go anywhere unless they continue to make those improvements. The other things from an industry driver point of view, has anybody heard of the Stuxnet that happened? Yep. Basically the virus that was able to come in and control the nuclear reactors and the purifiers, and I think it was in Iraq, and it basically destroyed the machines over time. So those type of things are very, very, very much of a concern to everybody. And then from a technology point of view, once again, everything that's being done in business is now also looking to be applied in manufacturing. So Internet of Things is a big thing that everybody's talking about. You know, we're going to connect all these different devices together and be able to move things around and manipulate things. Well, manufacturing systems have been doing that for years. It's really nothing new. But now how can we get more productive in how we're doing that? So the application of that. Big data is also extremely important. So being able to take that immense amount of information that's generated from a manufacturing process like a food plant, for example, and to be able to analyze it and understand what's going on to make improvements as part of that. So some of the major trends that we're dealing with overall from an investment driver, and this really does drive the investments. At the same time, and this is what I found in my career too, there's a big convergence between IT technology and operations technology. And this has happened from when I first started my career, for example, I'm sure before that too. So information technology, being able to basically provide workforce productivity applications for word processing, email to be able to communicate better, information databases to store the data, to analyze it, and then the financial systems, being able to go and store that information and become more productive from an accounting and from a raw material point of view and from a pricing point of view. And then over on the operational side, it's similar technologies, but just used by different people for different purposes. So you've got things going on like all these different machines that you're interacting with. Those machines have sensors on them. Those sensors are pulling information into a control system. That control system is manipulating things, but also storing the data and providing it for analytical purposes for everybody. IT people maintaining it, engineering people maintaining it. But it's come together. And you see this a lot inside of the organizations. When I first started working in the 1990s, there was a clear delineation between people working in IT and people working in operations management and engineering. Now the groups are coming together. In fact, they've got pretty much the same people working in a single group helping to maintain it for the betterment of both, because they really leverage all these things. I remember there was a control system I was working on at Honeywell, and one of the first ways we integrated IT with it is they started putting computer boards right in the control system. So it was like a one-for-one type of a setup where they would merge together the IT technology and the operations technology. Operations technology is also very much of a real-time system. So there's lots and lots of coordination that happens in sync at one time. So this valve opens, this valve closes, this thing happens as part of the plant, and things work well by doing that. So that real-time aspect is very important. Information technology is really about getting that information to the people so they can make the decisions. Now, how does this apply to big data? Now, from a data point of view, you could have looked at a chart like this on the left-hand side back in the 1980s, and you would have seen something exactly like that. Data turns into information, becomes knowledge, gives you wisdom to be able to do and make those decisions you want to do. And over the years, we've gotten better and better from a manufacturing technology point of view of doing that more efficiently, providing more insight into things, more visualization of what's going on. But if you look at big data, it's not just enough to get the data, analyze it, and talk about it to make decisions. You really need to close the loop, right? So getting the data out there, pulling it in, also sensing when conditions happen, and then collecting the data, taking it up, doing visibility and reporting on it, having the experts be able to analyze it and find out, is there a problem going on? Is there a correlation between two parts of the manufacturing organization that now I see what's going on so I can fix it? But then be able to take that and apply different technologies like workflow. So workflow to be able to route that problem over to correct it automatically, but also to go and actually embed the intelligence to make it more automatic. So as you see the problem, basically put in place automation to be able to more quickly fix the problem, and just it's a continuous improvement type of a process. A lot of people talk about the data from an analysis point of view, and that's very important. It's very important to have the data scientists and the experts to be able to look at it. But then also to complete it, taking that information and actually using it for something is very important too. That's something that our company is very, very big on, because we do both. From a manufacturing technology point of view, these are some of the major building blocks for software technology in the manufacturing sectors. And you can kind of think about it of all the things that are done before the plant's built and the things that are done after the plant's built and it's up and running. And as part of that, there are different applications that are used as part of this. And for years, manufacturing and automation systems have used a combination of hardware and software, but software has become very, very important because it can basically be molded and applied to exactly how your business runs. It's so much more flexible to be able to, and changeable to be able to do that. So engineering software and design software, that's where I can basically design the plant and make decisions on like the type of material I'm going to use, how much metal I have to use in the piping to be able to run at the optimal efficiency. So I can save massive amounts of money by doing that. I can also simulate the process. So I can take the whole plant, for example, for example, an oil refinery, and simulate all of the movement of the material, the things that are being done, the heating, the cooling, and I can guarantee, before I even build that plant, that it's going to run to this efficiency. And I can fine-tune it too so it runs even more efficiency. Less pollutants going into the air, less energy being required to run the process. And thirdly, what I can do is I can train the operators with that same model. So these models become very important. And where do we get models from? From data, right? These big data sets that we can derive models on how things actually behave and do that. So engineering software is very important. On the runtime side, the process control is really the heart of the whole plant. So that's where you have the automation systems and the software that provides set points to be able to optimize and run things. And they call it rudimentary control, which is a basic just opening valves and making sure the process is running safely. But then you can apply optimization software on that, can save millions and millions of dollars for people. So, for example, ExxonMobil, they use optimization software, and it saves them about $500 million a year in a typical plant, for example, to be able to do that for a large refinery. So great savings that come out of that. Extending that into operations management for things like traceability. So once I have all these things going on in my manufacturing plant, say I'm in a food industry and there's a contaminant that goes into a batch of material I'm producing, like cheese, I can then I can track through the whole system what happened and where that went once I discover it. And I can even do recalls of that material that went out into the marketplace more efficiently. So today, you can't really operate a food plant without having that traceability and quality management software. And then information management software is another thing. Being able to basically pull in lots of information from all these sensors and devices and different things, and even pulling in stranded asset data. So different things that, because one of the biggest sensors I have in a manufacturing plant is the people walking around doing things. So they can read gauges, they can see something going on, they can enter it in via a mobile device, and you can pull that information into the whole data set that you can leverage as part of that. And then using things, technologies which like real-time historians, which allow you to store thousands and thousands of data sets quickly, sub-second, and then pull that out and analyze it more efficiently as part of that, something a relational database can't do. So information management analysis becomes very important. And then finally, the plant maintenance systems. Being able to provide sensors out there that will detect when a machine is starting to trend to breaking down, so you can actually analyze that and do maintenance based upon when things need to have maintenance rather than when things would be done on a time basis. So, for example, your car, the oil sensor that you have in the more modern cars, it will tell you the engine oil life. That's more effective for when you're going to change the oil versus actually doing it on every 3 months or every 5,000 miles. You may not need it. So that saves them a massive amount of money. And that's what it is about manufacturing, is become more and more efficient, more safe as part of that. And there are some real vertical problems that can be solved by this technology out there. So, for example, oil and gas mining, water, wastewater, food and beverage. These are probably the 4 biggest industries that spend the most amount of money on technology and innovation because they make so much money as part of their overall processes. So getting more out of the ground, being able to simulate the behavior of an oil field and optimize how the different wells are behaving. Workforce enablement, being able to train your workers more efficiently, being able to optimize the process to reduce the amount of emissions that are going out from a power plant or from a oil refinery, for example. Mining is dealing with issues of remoteness. So we've mined just about everything we could out of readily available areas which are close to very populated places. Now we're going off into South Africa, we're going off into Latin America, we're going off into different parts of Eastern Europe, and that's where the mines are located. So being able to remotely control those systems from experts that don't necessarily want to move to that site becomes very important. Being able to optimize the energy usage, so I'm not burning a lot of gasoline or oil that's hard to get out there to that site. Being able to provide asset reliability, because if something breaks out there in the middle of Alaska, I'm not going to be able to fix it right away. So I want to be able to detect when things are trending and going bad. But it also goes beyond manufacturing into water, into smart cities. So aging infrastructure is a very much of a prominent thing that's going on right now. In fact, some of the water systems we have in the United States are still using hollowed out logs as piping to get the water to the residents. It's that old. They're like hundreds and 150 years old systems. So being able to track and provide better maintenance on those is important. Source water availability is very important for us in California, for example, and desalination will become a major piece that we'll have to use in the future here, and automation helps us with that. And in food and beverage, I talked a little bit about this, the consistency, the regulatory requirements, being able to report and analyze and make improvements in the process from a performance point of view are very important. And the solutions from a software point of view help to do that quite a bit. So from a technology point of view, we see software as very much of a game changer from an overall technology point of view, providing for people to do safer processing of their plants, to provide better worker safety, provide more productive plants overall, to be able to reduce the amount of energy they use, and to make better quality products. Smarter cities, where we can pull together the transportation system with the water system, with the electrical system, and provide better city services to customers. And then really that leads to a better life for everybody as part of that. So that's the kind of the philosophy we have, and that's the privilege I've had of working in the industry over the last 20 years.